Hi, welcome to Sunil Maths tutorial. In this video, we solve a problem depends upon Fourier series. Fourier series class number 6. Let us see the problem. Find the Fourier series of the function f of x is equals to 0 if minus pi less than x less than 0 and f of x is equals to pi x by 4 if 0 less than x less than pi. So clearly the function is defined in the interval minus pi to plus pi, and the function is discontinuous at 0. And also prove that pi square by 8 is equals to 1 plus 1 by 3 square plus 1 by 5 square plus and so on. So I write the given function. The function f of x is 0 whenever minus pi less than x less than 0, and f of x is equals to pi x by 4 if 0 less than x less than pi. And the Fourier series of the function f of x is given by in the interval minus pi comma pi is given by the formula f of x is equals to a naught by 2 plus summation n is equals to 1 to infinity a n cos nx plus summation n is equals to 1 to infinity bn sin nx. So right, we find one by one. First we are going to find a naught. A naught is equals to 1 by pi integral minus pi to pi f of x dx. But the function is discontinuous at 0. The function is discontinuous at 0. So the integral can be expressed like this: 1 by pi integral minus pi to 0 f of x dx plus integral 0 to pi f of x dx. Here 1 by pi is multiple for both the functions. By the definition of the function is 0 whenever minus pi less than x less than 0, and the function is pi x by 4 whenever 0 less than x less than pi. By applying this definition, we have here the value of the function is 0, here value of the function is pi x by 4. So you simply get 1 by pi integral 0 to pi f of x pi x by 4 dx. Here pi get cancelled, pi get cancelled. You simply get 1 by 4 integral x square by 2 limits 0 to pi. What you get finally? 4 2s are 8, 1 by 8, upper limit only pi square. So the value of the constant a naught is equals to pi square by 8. A naught is equals to pi square by 8. That's it. Next we are going to find an. An is equals to 1 by pi integral minus pi to pi f of x cos nx dx. Again we split the integral 1 by pi integral minus pi to pi f of x integral minus pi to 0. We are splitting minus pi to 0 f of x cos nx dx plus integral 0 to pi f of x cos nx dx. Again, by the definition of the function, here the function is 0, here the function is pi x by 4. So by substituting that, we simply get 1 by pi integral 0 to pi f of x pi x by 4 cos nx dx, which is clearly equivalent. Again pi get cancelled. 1 by 4 integral 0 to pi x cos nx dx. I am going to use Bernoulli's principle. 1 by 4 x integral cos nx sin nx by 4 sin nx by n minus again integral u dash 1 again integral sin nx minus of minus plus cos nx by n square, and the limits are 0 to pi, you observe that whenever 1 by 4 if you substitute pi there, pi sin n pi by n sin n pi by n plus cos n pi by n square, this is upper limit, minus lower limit 0 sin n into 0 by n plus cos 0 by n square. Apply both the limits. Here sin n pi is 0, sin 0 is 0. So this term completely vanishes. It becomes 0. This term also completely becomes 0. And already we know that cos n pi is equals to minus 1 power n. Cos n pi is equals to minus 1 power n. So you simply get here 1 by 4, 1 by 4 minus 1 power n by n square minus 1 by n square, minus 1 by n square. You observe that. So this can be simplified again like this. Here observe that. You simply write minus 1 power n minus 1 divided by 4n square, divided by 4n square. Therefore we conclude that an is equals to minus 1 power n minus 1 by 4n square. You can simplify again this by using even and odd concept. Minus 1 power n is equals to 1 if n is even, minus 1 if n is odd. So right, it is 0 if n is even, if n is even. It is minus 2 by 4n square, which is equals to minus 1 by 2n square if it is odd, if n is odd. Remember that. So we have two values for an. An is equals to 0 if n is even. An is equals to minus 1 by 2n square if n is odd. Next we have to calculate bn. Again, bn is equals to 1 by pi integral minus pi to plus pi f of x sin nx dx. Again split the integration. Integral 1 by pi integral minus pi to 0 f of x sin nx dx plus integral 0 to pi f of x sin nx dx. Here again in the interval from minus pi to 0, the value of f of x is 0. Here the value of f of x is pi x by 4. By substituting that we get the first integral completely becomes 0, 1 by pi integral 0 to pi x by 4 sin nx dx. Again which is equals to 1 by 4 integral 0 to pi x sin nx dx. I am going to use the UV rule. 1 by 4 x minus cos nx by n plus sin nx by n square. So limit 0 to pi. You observe that whenever n is equals to pi whenever x is equals to pi and x equal to 0, the second term completely vanishes because it becomes 0. Sin n pi is equals to 0 for all n belongs to z, and sin 0 also equivalent to 0. So the second term completely 0. We get the first term which is equals to 1 by 4 minus pi cos n pi by n. Again we know that if you substitute the lower limit x equal to 0 here, obviously second term is also 0. So simply 1 by 4 minus pi minus 1 power n by n, minus 1 power n by n. You can write like this, pi by 4n. Here is 1 minus and here is minus 1 power n. So you can write minus 1 power n plus 1, minus 1 power n plus 1. So this is known as bn. This is known as bn. So using all these values of, so bn is equals to pi by 4n minus 1 power n plus 1. Using all these values, in Fourier series expansion, in Fourier series expansion, we get f of x is equals to actually it is a naught by 2. F of x is equals to a naught by 2. We get a naught is pi square by 8. Pi square by 8. So you get pi square by 16 plus summation n is equals to 1 to infinity. Summation n is equals to 1 to infinity minus 1 power n minus 1 divided by 4n square into cos nx plus summation n is equals to 1 to infinity minus 1 power n to minus pi divided by 4n into sin nx. So now by expanding or removing the summation we get pi square by 16, pi square by 16, we can write minus pi square by 16 minus pi square by 16 minus 1 by 2 into 1 by 2 into, you can write like this, cos x plus 1 by 3 square cos 3x plus 1 by 5 square cos 5x minus and so on plus pi by 4 into sin x minus sin 2x minus sin 2x by 2 because of there is n plus sin 3x by 3 minus and so on. In the left side we have what is f of x. F of x is equals to, we have f of x is equals to something, in the different intervals we have minus pi less than x less than 0 and so on. Now put x equal to 0. Obviously put x equal to 0. If you put x equal to 0, sin x 0, sin 2x 0, sin 3x 0. So the second term of the Fourier series completely becomes 0. This term completely becomes 0. Now we get first term f of 0 is equals to pi square by 16 minus 1 by 2. Everybody knows that cos 0 degrees is equals to 1. So 1 plus 1 by 3 square plus 1 by 5 square plus and so on. Again this f of 0 is equals to 0. F of 0 is 0. So you get simply minus, let us write like this, pi square by 16 is equals to 1 by 2 into 1 plus 1 by 3 square plus 1 by 5 square plus and so on. 2 1s are 2 8s are. So from this you get pi square by 8 is equals to 1 plus 1 by 3 square plus 1 by 5 square plus and so on, which is required series. So you observe that this is the lengthy process, but if you know the integration well, then it is very easy to solve the problems. Right, before closing the video, I can explain one more time the integration of parts. X sin nx dx. This is in the form of integral uv dx. U is equals to x, v is equals to sin nx. U dash is equals to 1, u double dash is equals to 0. v1 is equals to integral v dx. Integral v dx means integral sin nx dx, which is equals to minus 1 by n cos nx. v2 is equals to integral v1 dx. If you are integrating this, you get minus 1 by n square sin nx. By applying Bernoulli's principle, integral uv dx is equals to uv1 minus u dash v2 plus u double dash v3 minus and so on. So what is integral? What is u here? X. What is v here? Sin nx dx is equals to uv1. You have to cross multiply like this. X into minus 1 by n cos nx minus, again there is a minus here, minus of minus plus 1 by n square sin nx. 1 by n square sin nx. Here you see here, whenever we calculate this bn, we get the same answer again, minus x cos nx by n plus sin nx by n square. Here also you get the same thing, minus cos nx by n plus 1 by n square sin nx. So if you know the Bernoulli's principle of integration, then Fourier series becomes very simple and easy. And some standard results are there. Sin pi is equals to 0, cos pi is equals to minus 1, cos n pi is equals to minus 1 power n for all natural numbers or for all integers z belongs to n belongs to z or z plus positive integers, if you conclude that. So keep learning, wish you all the best.